Imagine spending several $1 billion building a machine that can write software, analyze research, translate languages, and automate parts of company. Then, instead of protecting it like a trade secret, you publish the model weights so that strangers can download them, modify them, and run them without paying you for every answer. That sounds less like a business model and more like losing control of your most valuable asset. This is H2N, where we look closer at ideas that stop making sense when you follow the money. That trail begins with an apparent contradiction. Yet this is no longer a fringe experiment. Meta has pushed Llama into a huge developer ecosystem. Google has continued expanding Gemma. Mistral and DeepSeek have released powerful models that people can run outside their platforms. Even OpenAI, the company most associated with closed commercial models, released open-weight reasoning models in 2025. This does not mean artificial intelligence is suddenly free. Training still costs enormous amounts of money. Running a large model still requires chips, electricity, cooling, and engineers. Many of the strongest systems remain closed, and companies still charge for convenient access. But a pattern is becoming difficult to ignore. Some companies are deliberately making the model itself easier to obtain, even when building it was extremely expensive. Why? The obvious answer is generosity. The more interesting answer is strategy. They may have realized that the model is not where all the value will live. If intelligence becomes cheaper and widely available, the real advantage moves somewhere else, into the hardware, cloud platforms, developer tools, distribution channels, and applications surrounding it. In other words, they may be giving away the engine because they want to own the road. Before going further, we need to separate three ideas that are often mixed together. A free chatbot is a service somebody else is paying to operate. An open-weight model allows you to download its learned parameters, but it may not reveal the original training data or every detail of how it was built. A fully open-source system usually implies broader access to the code, documentation, and permissions needed to study or modify it. These are not the same thing. When a company releases model weights, it is not handing you a magical box that costs nothing. It is handing you a blueprint for behavior. You still need a machine capable of running it. You may need to compress it, fine-tune it, secure it, monitor it, and connect it to useful data. That distinction matters because the phrase giving away AI can be misleading. The company may give away one expensive layer while creating demand for several other layers. A downloadable model can increase demand for cloud servers. It can make specialized chips more valuable. It can encourage businesses to buy deployment software, security tools, fine-tuning services, or enterprise support. The model may cost $0 to download, while the complete working system costs a great deal. That is the first clue. Free AI is not necessarily the absence of a business model. Sometimes it is the beginning of one. There is another reason companies can afford to think this way. The price of useful AI capability has been falling unusually fast. Stanford's 2025 AI Index estimated that the cost of querying a model performing around the level of GPT 3.5 fell more than 280-fold between late 2022 and late 2024. During roughly the same period, smaller models became much more capable, and the performance gap between open-weight and closed models narrowed on several benchmarks. This does not mean frontier intelligence is cheap to create. Training the latest systems still requires vast capital. The important change is that yesterday's exceptional capability can become tomorrow's commodity. We have seen this pattern before. Storage was once expensive enough to shape how software was designed. Bandwidth once forced websites to avoid images and video. Computing power once belonged mainly to governments, universities, and giant corporations. Then supply improved, costs fell, and the center of value moved upward. When storage became cheap, companies stopped competing over who could save the smallest file and started competing over what people could do with enormous libraries of data. When bandwidth became abundant, value moved into streaming platforms, social networks, and cloud applications. AI may be entering a similar transition. If many models can summarize documents, generate code, and answer routine questions at acceptable quality, charging a premium for the raw capability becomes harder. Customers start comparing price, latency, privacy, customization, and reliability instead. The model does not disappear. It becomes one component inside a larger product. This is why releasing a capable model can be rational. A company may prefer to accelerate the decline in model prices before a rival can build a highly profitable toll booth around them. One of the most powerful strategies in technology is to make the thing your competitor sells as cheap as possible, especially when your own profits come from something next to it. Google did not need to charge consumers for Android. A widely distributed mobile operating system protected access to search, maps, advertising, and Google services. The free layer expanded the market for the profitable layer. The same logic appeared with web browsers. A browser became free because controlling how people reach the internet was more valuable than selling the browser itself. AI creates a similar opportunity. For a social platform, free models can improve recommendation systems, advertising tools, messaging products, and creator software. For a cloud provider, open models can generate demand for rented computing infrastructure. For a chip company, every new model deployment creates another reason to buy accelerators. This is why the open versus closed debate is not just philosophical. It is shaped by where each company already makes money. A company with a profitable ecosystem can afford to treat the model as a complement. A company whose main product is model access has a stronger reason to protect it. The disagreement is not simply about what is best for humanity. It is also about which layer each company wants the market to value. A model becomes influential when other people build on it. This is why download numbers matter, even when downloads do not directly produce revenue. Every developer who learns a model's tools, adapts it for a company, or teaches a team how to deploy it increases the probability that the same model family will be used again. Meta said in 2025 that Llama had passed 1 billion downloads. Google later reported hundreds of millions of Gemma downloads. Those figures do not tell us how many deployments became successful businesses, but they reveal the scale of the distribution contest. Developers are not ordinary customers. They are multipliers. One developer can build an application used by thousands of people. A consulting company can standardize one model across many clients. A university can train a generation of engineers on the same software stack. A cloud platform can make one model available with a single click. Over time, familiarity becomes an advantage. The model with the highest benchmark score does not automatically win if it is difficult to customize, poorly supported, or absent from the tools developers already use. A slightly weaker model can become more important if it is easier to run, cheaper to adapt, and available everywhere. This is how ecosystems form. First, a model attracts experimentation. Then tools appear around it. Tutorials, integrations, fine-tuned versions, monitoring systems, and specialized datasets make it easier to use. Each addition lowers the cost for the next adopter. Eventually, replacing the original model can become inconvenient, even if a better one exists. The strange result is that giving developers more freedom at the beginning can create a powerful position later. The control does not come from locking the model in a vault. It comes from becoming the default choice outside the vault. The word open suggests freedom from control. In practice, open models can create a different kind of dependence. Imagine a company downloads an open model and fine-tunes it on internal documents. It builds evaluation systems around that model's behavior. Employees learn how to prompt it. Engineers connect it to databases and business workflows. Security teams approve a particular deployment setup. Technically, the company can switch models whenever it wants. Operationally, switching may require months of testing. This is not the same as being trapped by a software license. It is closer to being committed by accumulated work. The more infrastructure built around a model family, the more expensive replacement becomes. The company that released the model can benefit without charging for every token. It may sell hosting, premium tools, support, specialized versions, or access to a broader platform. Even when third parties provide those services, the original model family gains influence over industry standards. This is why free can be a path to power rather than a surrender of power. The most valuable position may be owning the reference point. If developers compare new tools against your model, optimize hardware for your architecture, and design applications around your interfaces, you shape the market even when you do not collect money from every transaction. The model becomes a language that the rest of the industry learns to speak. There is also a practical reason open-weight models are gaining attention. Many organizations do not want their most sensitive information passing through an external chatbot. A hospital may need strict control over patient data. A bank may require detailed auditing. A government may want models running inside national infrastructure. A factory may need an AI system that works with private technical documents and cannot depend on an outside service staying online. For these buyers, a slightly less capable model under their control can be more valuable than a stronger model they cannot inspect or deploy privately. Open-weight systems make local and private deployment possible. They can be adapted to a language, industry, or narrow task. They can run in places where internet access is unreliable. They can also reduce dependence on one form provider. This is sometimes described as digital sovereignty, but the basic idea is simple. Organizations want intelligence without surrendering their data or their ability to choose where the system runs. That demand creates another business around free models. Cloud providers can offer managed hosting. Hardware companies can optimize machines for local inference. Startups can provide security, evaluation, and customization. Consultants can help companies adapt models to specialized work. Once again, the $0 download does not eliminate spending. It redirects spending into the ecosystem. At this point, it would be easy to conclude that open models will inevitably defeat closed ones. That is not certain. Frontier models remain extremely expensive to train. Companies that control them can update safety systems, improve reliability, and deliver a polished service without requiring customers to manage infrastructure. Most users do not want model weights. They want a product that works. Closed systems also provide an important advantage. The developer can change the model after release. Problems can be patched centrally. Access can be restricted if serious misuse appears. With an open weight model, the publisher loses much of that control once the files spread. Open models also create costs for the user. Running a model locally may sound independent, but somebody still has to maintain the hardware, protect the data, update the software, and investigate failures. There's a reason most people use cloud email instead of operating a mail server in their home. The likely future is not purely open or purely closed. It is a layer market. The most advanced models may remain proprietary for a period. Older or smaller models may become openly available. Companies may release some systems to build adoption while keeping their highest value capabilities inside paid products. OpenAI's own strategy now illustrates this mixture. It continues selling access to proprietary services while also offering open-weight GPTOSS models that developers can run on infrastructure they control. The contradiction is only apparent. One company can participate in both markets because the customers and use cases are different. When people imagine the AI business, they often picture a meter running beside a chatbot. Every question costs a little money, and the company with the smartest chatbot collects the largest bill. That may happen for some products. It may not describe the final shape of the industry. As models become more capable, smaller, and cheaper to run, raw intelligence may become less scarce. When that happens, value moves toward whatever remains difficult. Trusted distribution, private data, specialized workflows, computing infrastructure, security, and the ability to turn a model into something people rely on. This changes how we should interpret companies giving away model weights. They may not believe the technology is worthless. They may believe it is too important to remain a standalone product. A free model can weaken a competitor's pricing power. It can attract developers before a standard is established. It can create demand for clouds, chips, and services. It can become the base layer of thousands of products that the original company never had to invent. None of this guarantees success. A free model can be ignored. An ecosystem can fail to form. A company can spend billions and discover that somebody else captured the value. But the strategy itself is not irrational. The most important product in a new technology wave is not always the thing customers pay for directly. Sometimes it is the thing that makes every other product possible. That is the hidden logic behind giving AI away. They are not necessarily abandoning the race to monetize intelligence. They may be trying to decide where the finish line will be.